So for this tutorial, we will be using the Tinkercad software. So Tinkercad is a free software that you can access online. You can simply go to the website and create an account, and then you will see this screen. So from here, we can click on the Circuits tab, and then we can click Create New Circuit. And once it's loaded, we will see that it comes pre-named, and because we want this to be an LED circuit, we'll just name it LED circuit. So now that we've done that, we can head over to the search bar and look for an Arduino. And once we found it, we just drag and drop. And now we have our Arduino to work with. So now we need to find our LED, and that is going to be one of the first items that we can grab. So we just drag it and drop it, and just like that, we're ready to go. So now I want to talk a little bit more about the LED and specifically about how it's polarized. What a polarized element means is that the current within the element can only flow in one direction. The current must flow from the source to the anode, which is what I'm highlighting, and then through the LED to the cathode, and then out of the LED into the rest of the circuit. So that means we have to draw our cathode to our grounding pin, and then our anode to just any pin. Here I pick 13. And also we can change the color of the wires. And while that's not terribly significant here, it becomes more important when you're dealing with more complex circuits and you need to be able to tell the wires apart. So now we start our simulation, and as you can see, our LED is nice and bright and it's blinking, but unfortunately our LED does have a warning sign next to it. And this is because we're actually running too much current through it. In real life, if you were to run this, it would probably break the LED. So in order to fix that, we need to put a resistor into the circuit. So now we can change the resistance of the resistor within the program, and as we change the resistance, you'll notice that the colors change. For example, if I were to set it to 225, the colors will be different. And that's because in real life, we use color coding on resistors in order to determine what the resistance value is. And so here we just need to insert it into the circuit, and we can do it by taking this wire and connecting it to there, and then taking the anode and connecting it to the terminal. And now if we start the simulation, the light will flash on and off, and we no longer have a warning sign. Great. So now I just wanted to talk a little bit about the code within the program. So over here we have the code in block form, and what that means is that we can examine it as a very basic series of blocks. So here we set our built-in LED to high, which means on in this case, and we wait for 1 second, and then we set it to low or off, and we wait for 1 second, and then that is why it will flicker on and off for the same amount of time. But what if we want to change this? Let's say we want to set the time that it's on to 2 seconds. Well, we can do that there, and once we start the simulation, we'll see that it's on for much longer than it's off. So blocks are a great way to visualize it, but there are better ways to do it, and specifically, you can look at it in the text. Now, we'll talk about this more in the next video, but I just wanted to highlight a couple of different things. So first, you can see that this is set to pin 13, which is where the resistor plugged into the LED is plugged into, and it's going to be set to high, which we know means on, and it'll be on for 2000. So the Arduino code acts in milliseconds, and so whenever you input a time value for something to be on, you have to set it in milliseconds, and in this case, 2000 milliseconds would make 1 second. And then it will go to pin 13 and set it to off and hold that there for 1000 milliseconds or 1 second. So I hope you've enjoyed this tutorial, and it's been a pleasure teaching you about Arduino.